Hi, it's Lonnie, and today we're going to be taking a look at a few of these LCD screens that I bought on eBay. And these are just parallel LCD screens. Let's run of the mill. They got the HD44780 chip, the Hitachi driver, and one thing I kind of liked about these is a couple of things. One, they're cheap. They're like $2 on eBay a piece shipped, and they're universally supported. Like, you can even use these with the you can use them with the Arduino MSP430, the MSP430 with the Energia IDE. You can use them, as far as I know, Parallax. Everybody supports these, so this is a good way to bring a display unit to your project for not a lot of money. And like I said, these are $2 on eBay, and I've seen them as high as like $12, $13 on sites like SparkFun, which, you know, nothing against those guys. They're trying to make some money, but just do yourself a favor, get these on eBay. Let's get a little close up of these. And today we're going to be doing, I'm going to be using these in a couple of different applications. Number one, I'm going to try it with just Arduino, which is easy. There's a built-in LCD library. And number two, I'm going to be trying them with the MSP430 Launchpad. And then the third thing we're going to be doing is I'm going to try it with the MSP430 just on a breadboard, because I'll show you guys how easy it is to just take a couple voltage regulators, a 5-volt and a 3.3-volt regulator, and use a 5-volt device with a 3.3-volt MSP430. So let's get started. These little LCD screens didn't come with any kind of headers soldered on, I guess. Okay, now just for full disclosure, I want to let y'all know that for this portion I am using a tutorial at learn.adafruit.com, and there's some really good stuff there. I'm going to put the link into the video, but it's learn.adafruit.com, and I'll just go step by step for hooking this up. Okay, so we've got our LCD with the headers soldered on and plugged into this breadboard here. So the next thing that we need to do is we're going to do the 5-volt from the Arduino to the red rail and ground to the blue rail. Okay, that's pretty simple. And I'm using a let's see if I can get a little better light here. And I'm going to be using a Arduino Uno for this section. Yeah, that might be a little better. So we're going to go from 5-volt rail, or 5-volt with Arduino, I should say. It's right here. Maybe I'll get a little zoom. Okay, we got 5-volt there. Positive rail here. We're going to go ground. To the minus rail. Okay. Now we're going to connect up the backlight, and I am following right along with the tutorial. Next we'll connect up the backlight for the LCD. Connect pin 16 to ground and pin 15 to plus 5 volts. Okay, 16 is going to ground, and they're talking about the pins on the LCD. Okay, so that's 16 all the way over here. we're just going to take that to ground. I'm going to make this nice and messy by the time I get done, which is fine. We are on a breadboard. Okay, and then it said 15 to the plus 5 volts. Okay, like that. Alright. Well, this actually says through a series resistor. To calculate the value of the series resistor, look at the maximum backlight current. Okay, and the backlight current in the typical voltage drop from the data sheet. Subtract the voltage drop from 5 volts. Okay, this particular LCD here, it calls for 5 volts for the backlight, so we're fine. Okay, connect the Arduino up to power, and you'll notice the backlight lights up. And it does. Very good. Next, let's place the contrast pot. It goes on the side near pin 1. Okay. Okay, I'm back in. This potentiometer here is the same value. It happened to fit a little better. I do need to buy some more potentiometers. Okay, so one side of the pot goes to plus 5 volts. Right, I'll take the right side of the pot to plus 5 volts. Okay, and the other side goes to ground. To ground. The middle connects to pin 3. It's going to be pin 3. The middle, which is aka the wiper, goes to pin 3, which is 1, 2, 3. There. Okay. I don't know if it's going to work yet or not. I don't see anything. Might have to have the logic running. Okay, now we'll wire up the logic of the LCD. This is separate from the backlight. Pin 1 is ground, and pin 2 is plus 5 volts. Okay, so now we have to actually power the LCD. The backlight's getting power, but the LCD itself is not. So let's see, pin 1 is ground. Use green. I've got quite a few connections already made, and we're not even doing anything yet. Okay, and pin 2 is plus 5 volts. Okay, now turn on the Arduino. Well, I already had it on, oops. Turn on the Arduino, you'll see the backlight light up, if there is one. And you can also twist the pot to see the first line of rectangles appear. Oh, there we go. There they are. And I'm not using the right value pot, but I mean, if you think about it, if you want a 10K pot and you use an 85K pot, you'll just have, maybe your resolution won't be fantastic, but it'll still work. It works fine. Okay, good. Alrighty. This means that you've got the logic, backlight, and contrast all worked out. Don't keep going until you've got this figured out. Okay. Bus wiring. Now we'll finish up the wiring by connecting the data lines. There are 11 bus lines, D0 through D7, and RS, EN, and RW.
D0 to D7 are the pins that have the raw data we send to the display. The RS pin lets the microcontroller tell the LCD whether it wants to display that data or whether it is a command byte, like change position of the cursor. The EN pin is the enable pin we use to tell the LCD when data is ready for reading. The RW pin is used to set the direction, whether we want to write to the display or read from it, less common. The good news is not all these pins are necessary for us to connect to the microcontroller. Okay, so to recap, I'm just kind of scrolling down. If you're following along, it's learn.adafruit.com/character-lcds/wiring-a-character-lcd. Or you can go to their 16x2 LCD page and find it there. Okay, so to recap, we need 6 pins: RS, EN, D7, D6, D5, and D4 to talk to the LCD. And let me zoom in so y'all can see those pins a little better. You should be able to see the, there we go, you should be able to see the markings a little bit. As mentioned, we will not be using the RW pin, so we can tie it to ground. Okay, put RW, if I can see it. W's right here. We're going to ground it out. I guess they don't want a floating pin to have some kind of phantom character. Okay, next is RS pin number 4. Use a brown wire to connect it to Arduino's digital pin 7. Okay, I'm not going to use brown. I'm going to use green. It doesn't matter. Next is RS pin number 4. Okay. Pin number 4, and we're going to digital pin 7. On the Arduino, let me back out a little bit. Okay, pin 7. Next is EN pin number 6. Going to Arduino digital pin 8. Number 6 goes to Arduino 8. Okay, now we'll wire up the data pins. DB7 pin number 14 goes to Arduino 12. And if I look like a noob trying to do this, that's because I am. I'm a noob and I've never used a parallel LCD before. I've used serial and I've used the, well, I've actually used parallel LCD with the LCD shield. That's the same LCD as this one. Okay, pin number 14 to 12. Whenever I present these videos, I don't present them as somebody that's an expert. I'm just a normal guy learning just like anybody else. Okay. Next, the remaining 3 data lines, DB6, DB5, DB4, which go to 11, 10, and 9 on the Arduino. Okay, so we got DB6, to 11. Okay. DB5 to 10. Need some longer jumpers. So. Okay, E5 goes to 10. And DB4 and DB4 goes to 9. Okay, we're in. We're getting some kind of weird data here. I don't know what that is. You can see it. I'm not even sure what program is running on this Arduino right now. So we're just getting some kind of random noise on one of those data pins. Alright, so now we're going to be uploading the software. Okay, and now this is the website I've been referencing. It's the Adafruit Learning System, using a character LCD, and if you go through, it shows you exactly how to. This is the second page or so, but she shows you exactly how to wire everything up. And I need to open up the file examples, LiquidCrystal, Hello World example sketch. Okay. So I'm going to go Arduino. And I'm running the Uno here. So board Uno, serial port. Not sure. Maybe COM3. We'll try that first. And we're going to open up. Let's see. She said LiquidCrystal Hello World. And we need to look for this line and change it to these pins, okay? To match the pin table we just made. Right? We'll just plug it in right here. And I'll just comment out this line. Okay, let's see if there's anything else we need to do. Now you can compile and upload the sketch. Okay, we're going to do that now. Upload. Now I get to find out if my Arduino is actually on COM3 or not. And it says done uploading. Let's go take a look. Okay, and it looks like we have success here. We've got Hello World, and it's doing a little countdown, or count up, I should say. And our contrast is working just fine. Okay, success. Okay, so now I've proven that I can get everything to work with the Arduino. And our next order of business, we're going to use this Launchpad instead. See if we can get everything up and running. I'm going to go ahead and pull everything out. I'm going to rebuild it using the Launchpad. So I'm just going to yank everything out of here. Including the pot connections, and we're going to start fresh. And the cool thing about the Launchpad is the pin numbers on the Launchpad correspond to the digital pin numbers on the Uno. So whenever you use an Energia, so if I want to use digital pin 10 on the Uno, I just go to pin 10 on the Launchpad, which would be let's see our pin count starts over here at 1 to 10, and then 11 to 20. So let's get started wiring this up, and I'm going to go back to the Adafruit thing. And I also want to mention one other thing is I did modify this Launchpad board. You can see I added jumpers here and here. Those are 5-volt test points at the input for the USB. You can use that to provide the 5-volt power in this case. But I have a feeling that this thing's going to work fine with 3.3 volts, so I might just go ahead and try it like that. So, give me 1 sec. I'm going to grab some patch cords. I'll be right back. Okay, so we're going to start making our connections. First thing we're going to do is connect our ground and power from, I can't remember which is which actually, which is ground and which is hot here. And it doesn't say, so I'm going to have to test it real quick. A multimeter. Okay, so I'm just going to test these test points to see which one is negative and which one is positive. And I'm getting a negative 4.88 volts there. And now this is 4.88 volts here. So it looks like the ground is on the right side. And the hot is on the left. Put this on this side. And I'm using these groovy little, these are called DuPont connectors. You got male and female ends. These are really nice. So for whatever reason, this Launchpad came with all male headers already soldered onto it, and I couldn't be bothered to put the female headers on, so this is an easier way to go. These are also good for hooking up servos and things like that. Okay, so got that done. And I need to bring the power over to the LCD, and I believe it was, let's see, ground. Yeah, pin 16 goes to ground, and pin 15 goes to 5 volts. Okay, and we've got power and our backlight. Okay, connect Arduino up to power. Already done. contrast pot. Connect one side of the pot to 5 volts, which I'm just going through all this again. We can go the right side, it doesn't matter which, go right side to plus 5 volts. And we're going left side of our pot to ground. And we're going middle, or the wiper of our pot connects to pin 3 on the LCD. Okay. Now we'll wire up the logic. Pin 1 is ground. This is powering, again, this is powering the LCD itself and not just the backlight. You have separate power for the LCD and the backlight, and then I'll do a quick potentiometer test, working fine again. Okay, RW, we'll get tied to ground again. And RW is right, looks like it's pin number 1, 2, 3, 4, 5. We tie that to ground, and we have a mess on our hands again with these friggin' wires everywhere. Okay, pin number 4, go to digital pin 7. Okay, and okay, pin 4, go to digital pin 7. So we got 1, 2, 3, 4, 5, 6, 7. On the launch pad, that's labeled as a P1.5. That's number 4 here. Okay, pin 6 goes to Arduino Digital 8. Okay, that's 6. Going to 8 on the launch pad. Okay, DB7, which is pin number 14 on the LCD. It's going to Arduino number 12. I haven't really checked all these my pin map for the Energia pin map for Launchpad, but I'm hoping it's going to work. Okay, next to the remaining 3 data lines, let's see, DB6, DB5, and DB4 goes to 11, 10, and 9. Okay. Got DB6. Okay, D6. Goes to 11. I'm not using any particular colors here, just whatever. Oh wait, put that. Vision's not so good. I put that in the wrong one. It's DB6 here. I'll move it over. Okay, and then we're going to do DB5. Going to 10. It's right here. And if it ends up that this this launch pad, these pin numbers don't work, we can just redo the pin map. It's not a big deal. But I'd like to keep it the same if we can. For now, I'm just going to assume it can be the same. If I have to go back and fix it, I will. And then, let's see, DB4 is getting connected to pin number 9. Alright, and now I'm going to switch over to the PC for a minute. Okay, I'm back on the PC side of things. I've got Arduino open. Now I'm going to open up my Energia program. And we're going to go to examples, LiquidCrystal. We'll do Hello World again. And let me look at their pin map. So they actually show you, I didn't see this, I didn't pay attention a minute ago, but they actually show you all the connections to make. And they show you the Launchpad equivalents for each one. But I'm going to try my... Oh, that's weird. They actually use these pin assignments. I'll comment this out. I'm going to paste in the ones just like we used a minute ago. Hopefully that's going to work. I'm going to check out my COM 11, I guess that's it. Board, Launchpad with the 2553. That is what we're using. And let's try and upload the sketch. It'd be interesting to see how big this sketch is. It's actually, it compiles smaller. If y'all saw that, 1824 bytes written. It compiled, the Arduino version actually compiled to 25, like 2.5K. So this is actually a lot smaller. Okay, I'm going to switch back over to the camera view and we'll take a look at what we got. Okay, here we go, and now we're running. This is the LCD running the same exact code, the Arduino code. This time we're on a Launchpad, so and we're getting our 5 volts from the 2 test points on the USB input, and it's working just fine. It's working perfectly. See, our contrast adjustment's working fine and everything, so we're good to go. And one thing I wanted to test is I wanted to see if when we're using the Launchpad, if this thing will work with 3.3 volts. So I'm going to give that a shot now. Unplug first, and I'm going to move right side. This was the ground here. And I'm going to move this VCC here. So now we should be looking at 3.3 volts feeding, and hopefully it's not going to fry my board or my LCD. And oh wow, I gotta take all the attenuation out of this pot. Like, that's fully unattenuated, and it's a little dim. Turn this light out, you can see it better, or maybe it's worse when I turn the light on. This looks different than it does in real life. So if I zoom in a little bit, there we go, that looks better. But that's the that's the LCD running on 3.3 volts instead of 5, and it's working fine. It's dimmer, and it looks like the refresh is like really, like I'm watching these seconds on here, and the refresh is really slow and shitty, but it is working. So in a pinch you can use that. Okay. Interesting. Let's see what happens. I swapped it out hot. It looks like it's freaking out. So try to reset here. Now it's fine again. Okay, so good. That's working on the. That's working using the Launchpad board, and we're going to. I'm going to try one more thing. Since this video ain't quite long enough, I'm going to try moving this chip straight on the breadboard, and we're going to run it straight from the chip and eliminate the launch pad. So I'll be right back. Get set up. Okay, first thing I'm going to do is I'm going to go ahead and rip the power down. I'm going to rip all this stuff out. We're going to start fresh one more time. Because we're going to take a little bit of a different approach here. And I'm going to go ahead and pull carefully, if I can. These chips are kind of hard to pry out, and they're very prone to getting bent. The thing to do is to like loosen up one side and come back and loosen up the other. I'm using a toothpick here. There we go, pop right out. Now we've already got this chip programmed with our Hello World program on it, so we should be able to just pop it in. Okay, I'm going to just pop it into our breadboard here. Carefully. These pins are real prone to getting bent. Okay, and just as a reminder, look at this board here, and we're going to start looking at your chip. This is a pin. It's pin 1 through 10 and 11 through 20. So the first thing I'm going to do is I'm going to set up my input. Let me find my voltage regulators, and I'll be right back. Okay, I'm going to be playing around with a few voltage regulators in this section. To move this on the breadboard, I've got a it's an L7805 voltage regulator. Just going to put it on the breadboard over here. And basically this is talk about what the pins are. Basically you have input on the left, ground in the middle, and output on the right. And I can't remember what the input range is. We're going to be coming in with 9 volts, which is fine. And we're going to be looking for 5 volts output on the right, which we're going to use for the rail to power the backlight and to actually power the LCD. So I'm going to plug this into the breadboard. And we're going to go 9 volts in there. And ground here. Okay. And I'm going to go ahead and patch that over. We're going to have several different rails going here. But we're going to call this this right here is going to be our 5 volt rail. Set this up. go ahead and give this a quick test with the multimeter just to make sure we're getting our expected 5 volts off of this rail now. Grab some alligator clips to test with. One of my next purchases is definitely going to be a new multimeter and also some better test leads, because these leads are terrible. I end up having to use alligator clips in between. Okay, and we're getting, if you guys can see that, but we got 9 volts in and we're getting 5.01 volts out, so that's perfect. And whenever you use voltage regulators, you might want to kind of tap, just kind of feel the heat sink, make sure you're not putting too much heat out, because the extra voltage is coming in, it's getting dissipated on that heat sink. 9 to 5 volts isn't bad, but I have felt them get kind of warm going from like 12 volts down to 5. And let me take a look. Give y'all the input range. Yeah, the voltage input range. DC input. Let's see. Looks like it's 5 to 18 volts, I believe. I don't know. You need to check the. I'm not looking at the right data sheet. Let's see, 7805. Okay, here we go. 7805. Seeing all kind of different numbers. Look like 7 to 25 volts. Okay, but in any event, now we have a 5 volt rail set up. Now we're going to have to set up another rail for 3.3 volts to power the MSP430. So let me grab another voltage regulator. Be right back. Let me find it. Okay, so this is a LM1117 regulator, and it's kind of confusing. I looked at the data sheet just now for this regulator, and it comes in several different varieties. Some of them, it's either it's a linear amplifier, and they have some that are set up for variable use, where you can pay attention, hook this up. Variable use, where you use a couple of resistors to determine the output, and then some of them are set up for exact voltages. And I think I ordered this. I'm not sure. I haven't researched the part number, but I believe I ordered this one for 3.3 volts. So I'm going to find out now. Okay. I'm going to hook this up over here on this rail. This will be my 3.3 volt rail, if this works. And I'll put a couple of little test leads in, so I can see what kind of output we're getting here. let's see what we got. Not what I was expecting. Negative 0.5 volts and falling. That's weird. Alright, I'll be right back. Let me see what else I got. Okay, as it turns out, I actually have this wired up wrong. I just look at the data sheet and I assume the inputs and outputs will be in the same place, but they're not. Let's see. If you look at the data sheet, the input voltage goes on the right. And I could tell something was wrong because the heat sink was getting really hot. Okay, input voltage on the right. The ground is on the left. Okay. I'll hook this rail's ground up. There. And the output is actually the middle pin. So all voltage regulators are not the same. Now let's see what we have on our multimeter now. And now, perfect, we have exactly negative 3.3 volts. So I'm going to have to, this voltage regulator actually puts out a negative 3.3 volts. So I'm going to have to remember that. Just reverse the power and ground, and now I've got 3.3 volts coming out on this rail right here. So I've got, quick recap, I've got 5 volts on this rail and 3.3 volts on this rail. So we should be good to go. I'm going to start hooking up my LCD. I'll be right back. Okay, so things are a little different this time because we have to actually take care of our MSP430 chip. And okay, this is the VCC right here. I'm going to tie that into our 3.3 volt rail. Okay, and then the ground pin is up here on the other side. And this might be helpful to y'all. What I'm doing is I have my say I have my Launchpad board just out of the screen, and I have it sitting in the same orientation as the chip, so I can kind of reference the little chart there in case you forget what pin is what. Okay, so we're going ground to the ground here. I'm not sure how this negative 3.3 is going to end up working out. I'm not sure if that's good, just flip-flopping it over, because I'm actually putting negative 3.3 volts on the ground. That's probably not going to work. Okay, I took a look around and I do not have any, I don't have any positive 3.3 volt regulators. So I'm going to go ahead and try this. I think it might work because the reference is 3.3 volts. I'm actually feeding negative 3.3 into ground here and using the ground side for the positive voltage. I don't know if that's going to work or not, but I'll give it a try. The thing I need to be careful is I need to be careful not to use have the ground tie this ground anywhere into here, because I think that'll jack this up. I'm not sure if these have to have a common ground or not to work. We're going to find out. Might be kind of an interesting thing. So let's get on with it. I'll also need to take the reset pin and I need to tie it high. Reset is, looks like pins, pin 16, 11, 12, 13, 14, 15, 16. It's getting tied high. This might be just an epic failure. I might even smoke something here. The bad voltage. I just don't have a 3.3 volt regulator. I'd probably be better off just putting 5 volts in here. It could probably handle it. Might smoke it, I'm not sure. Okay, moving on. The MSP430 should be getting good power, and it's not smoking yet, so that's a good sign. And I'm going to go back to my Adafruit website. Okay, plus 5 volts to the red rail, blah blah. No, we got 5 volts here, 3.3 here. And our voltage regulators are cool for now. I'm going to keep monitoring that. (16) to ground and 15 to 5 volts. And the way I have this wired up, again, I'm going to have to be very careful not to have a common ground in between the Arduino and this, and I'm not sure if that may not work. It's probably going to have a ground between the two. Let's see how far I can get anyway. Okay, backlight lights up. Okay, contrast circuit. Okay, wiper's going to pin 3. Got all these DuPont cables I need to sort through. Okay, wiper to pin 3. Got plus 5 on one side, or it doesn't matter which side is which, and the other side goes to ground. So I got the left side going to ground. The middle pin of the potentiometer is going to the pin 3 on the LCD, and the right side is going to plus 5. Okay, now I'll have to actually power the LCD. Pin 1 is ground and pin 2 is 5 volts. And that's what it looks like when there's no ground connected yet. And there we go, and now we should be good. Yeah, we can adjust the pot. So that's working fine. Okay, RW is going to ground. And there again, I have to be very careful not to use to tie any grounds between the MSP430 and the backlight, because they're working on different grounds. I'm not sure if it's going to work. Okay, use a brown wire to connect it to Arduino's digital pin number 7. RS pin is going to go to 7. And I need some more jumpers. Jumpers I have are so short. Okay, RS. Digital pin 7. Okay, so we got 1, 2, 3, 4, 5, 6, 7 right here. EN pin number 6 to number 8 on Arduino. Okay, EN to pin 8 on the Arduino. DB7 goes to 12. It's 11 and 12. Okay. And it's looking like I may not have to tie a ground in between. I'm not sure if they have to have a common ground or not. We're gonna find out. Okay, DB6, 6, 5, and 4 got 11, 10, and 9. Okay. 6. Going to 11. Okay, 5 goes to 10, which is right here. Okay, and 4, DB4. Going to 9, right next to 10. Okay, now nothing yet. I think I might need to reset it for sure, among other things. I'm not really expecting this to work. So far, this is not working at all. This looks like a fail. And just as an exercise, let me try. I'm going to try using this regulated voltage coming off of the Launchpad board here, and I'm sure that's what the problem is going to be. Okay, there's VCC here, and here's ground here. Okay, so I'm going to pull VCC and ground from the Arduino on the breadboard. And I've got ground here. And I've got VCC here. And this is coming off of the voltage regulator on the Launchpad board. Okay, now let's do a little reset action here. Still not good, right? So now I'm going to see what happens when I tie in my ground. And this is going to just tie, I don't have to do it here, I can do it over here. This is going to tie the ground of the MSP430 and with the ground over here, I guess on the 5-volt rail. This will be fine. Yeah, let me do another reset. I thought that was going to fix us up, but it's not. Now I'm kind of at a loss. Not sure exactly what's going on here. Oh, well, okay. The reset pin, I need to tie it high. Still no good. And I'm not positive about my reset pin. Let me try tying it low. Still no good. This looks like a moment of fail. I guess and now I've got so much shit going on this board. It's hard to follow everything. But I'm going to take the voltage regulator out here. I'm going to pull all these wires out. I don't even know what this one is. There we go. Okay, let me double check everything. Now we got this voltage regulator feeding the 5-volt rail. And I've got, let's see, VCC and ground feeding MSP430. And the chip is in the right orientation. Okay. And I'm also tying the two grounds together here. So my 5-volt rail is tied into that ground. Okay, so everything's sharing a common ground here. LCD's getting power, that's not the problem. Let me look something up real quick. Okay, so I just went through and validated all my connections and it started working. Now I must have some loose wires or something somewhere. Some kind of problem. Because now you can see it's kind of flaking out. Reset it. Now I'm getting nothing again. something flaky going on here. It's one of these patch cords probably. So now I'm at least getting something on the screen. There we go. This patch cords are just not making a good connection. It's a big mess. But you can see now getting the expected hello world. And it's counting. It's working just fine. So this is the LCD working on the MSP430 chip 2553, and all I'm using this for is the Launchpad board for. It's because I do not have a 3.3 volt regulator, and this is the easiest way to do it. I could have set up a low voltage divider, but I didn't feel like it. So thanks for watching, and I hope you guys get some good use out of these, because if you look at this circuit right here, you've got not a lot of parts, and you know, as far as cost, these are about $2 a piece. You can pick these Launchpad, not Launchpad, MSP430 chips up for around, you know, $1. Potentiometer, that might run you 50 cents. Voltage regulator, 50 cents. So we're talking about well less than $5 to get this little project here made with the LCD screen. So thanks for watching. Bye bye. Okay, I'm back. Real quick, just wanted to show you guys. I did, and this is not something I recommend doing, but I did go ahead and hook up VCC on my chip to 5 volts. So I'm running the MSP430 on 5 volts, and so far it's not, doesn't feel hot or anything. It didn't smoke, so it's not the end of the world. I don't know what would happen like through prolonged use like this. It might have a shorter lifespan or something. I don't know, but so far it's working fine. Don't recommend you do it, but it is working for me on 5 volts. Okay, bye bye.